For our second day of game show week, we are going to talk about the game show Deal or No Deal with Howie Mandel. So, I don't know if you know a lot about this show, but basically, you have 26 briefcases that you start with, and those briefcases could have anywhere from 1 penny in it to $1 million in the briefcases. So, the goal of the game is to try to select the briefcase that has $1 million at the very beginning. So obviously, the probability of doing that is one briefcase out of the 26 briefcases, so 1/26. But as you go along, you're going to start to select different briefcases. So you might select 3 briefcases at the beginning, and one of them might have 500,000 in it. One of them might have 750,000 in it, and one of them might have 100,000 in it. Then there's going to be a banker who decides an offer that they're going to give you to just stop the game completely. So that offer could be a really great offer, and you're like, yes, I just won $300,000 playing this game. Or it could be a really terrible offer, and you're like, you know what, maybe my briefcase still has $1 million in it. So I have a picture on the right, if you remember, Meghan Markle. She married Prince Harry. She was a deal or no deal girl. She was briefcase number 11 back in the day. But here are the different values that we can get. So you could have 1 cent, $1, $5, and so on, and all the way up to $1 million. Some people have $1 million, but often they take the deal from this banker. So let me give you kind of the idea, the mathematical thinking behind the banker. So let's say your teacher's raffling off a prize in your class, and the class has a total of 20 students. Each one of you decides that you're going to pay $1 for the chance to win, but the prize is only 50 cents. Would you play that raffle? No one would play this raffle because you would be losing 50 cents at most, right? So we don't want to play this raffle. But let's say there's another teacher in the school. So across the hall, this other teacher has a class of 20 students, and he has each student pay $1 to enter the raffle. But now the prize is $1,000. Ooh. So your chance of winning, your probability of winning, is 1 out of 20, but your payoff is much bigger. Instead of being 50 cents, you now are winning $1,000. So you're making $999. Yeah, you would definitely play. So even though your probability of winning is the same, the rewards are so much greater that you're like, you know what, I'm going to risk it. I'm going to play this game. So this introduces the idea of expected value, and expected value is really useful to us in real life. Like, we want to know, should we play this game? Should we play the lottery? Should we, enter these raffles? What's the probability of, winning? Well, my probability doesn't change, but my outcome might be better. I might have a better chance at winning something. So basically, to find the expected value, you multiply your probability of winning a certain prize times the prize value. And you keep doing that for all of the different prizes. So if you had a raffle where you're raffling off like 10 items, and each time your probability changes because maybe now there's one less ticket in the raffle, then you would keep multiplying probability times the amount of the prize, probability times the amount of the prize until you add them all together. So with deal and no deal, our probability is going to change each time. Each time we open a briefcase, we have one less briefcase for the next problem. So we want to know, what is the fair offer from the banker? Does this banker use expected value? They should, right? They should give you a fair deal. But unfortunately, on deal and no deal, it's always a little bit less. The banker doesn't want to give you a fair deal. They want to kind of rip you off in a way. So we're going to experiment and see what expected value would be for different prizes. And we'll do this using Microsoft Excel. So if you have Excel, you can kind of pull it up and try it along with me. So how do we decide what a good deal is? So what do we do with this expected value type thing? So what I did in Excel is I kind of created 3 columns. I put cases, my total number of cases that are left basically, and then my prize amounts. So I got my prize amounts from this image, which is from deal or no deal, which says that the one case might be 1 cent, the next one might be $1, $5, $10, and so on. So if the dealer was going to give you a deal at the very beginning of the game, then we can say equals sum down here. And when you put a parenthesis, you can drag all of these ones together. So what it's doing is it's adding up all of those ones to get a total of 26. So that's the total number of cases that we have right now. Make that a little bigger. Now the sum of the remaining prizes, we do the same thing. So we could do equals sum, and then we can drag all those as well. All right. So that would be $3,418,416.01. So each of these prizes would be multiplied by the probability 1 over 26. So I'd have 1 cent times 1 over 26, 1 times 1 over 26, 5 times 1 over 26, and I would add those all together. Well, if they're all the same probability, then we can just find the total sum and multiply. So I'm going to do equals, I'm going to take this cell, so I click it, and then I do Shift 8, which gives me an asterisk, and I do 1 over 26, like that, and I get that answer. So the expected value would be around $131,000. Now, if I want this to compute it as I go and change this 26, I could do that, because I could just say that cell divided by, and then I click on this cell and it highlights it. So when it's reading the cell number, and this is why we call it Excel, because they're cells, we have C28, which is the column, letter, and the row number, divided by B28. And then when we hit enter, it gives us that number. Okay, so here's what we're going to do. As we delete cases, so let's say I open up case number 20 at the beginning, and I'm like, oh man, I just lost $100,000. I'm going to delete it, so it's gone. And it's going to adjust my different numbers. So let's say I open up case number 26. When I delete it, I now have 24 cases, and I delete that. Oh man, now I'm down to 107,000. And let's say I open up the big one. I open up that $1 million. I'm like, oh man, my $1 million is gone. Well, the banker doesn't have a lot of incentive to give you a good offer. So the banker might offer you around 68,000, right? So what happens on Deal or No Deal is this expected value is kind of like the fair deal. What should the banker give you? But oftentimes, instead of giving you that $68,192, he might offer you, or she might offer you, $50,000, right? So your expected value is still larger than the offer that they're giving you. So then maybe the next round you're like, oh, I'm going to pass on that $50,000 or $68,000, whatever they offer, and then you open up low ones. So you open up the 3 lowest ones. Well, now your value has increased, right? Because you got rid of some of those lower amounts on the board, making it more probable that you're going to get a higher amount. So the banker should give you a better offer then. So that's kind of the mathematics between deal or no deal. So no question for you today, but I do want you to try to do this in Excel, because Excel is a great program to use for any career. So if you want to be an engineer someday, or an actuary, that's a mathematician who deals with probabilities, you can use Excel all the time. All right, good luck.